Okay, so a couple things that we've already learned is when solving a system of equations by graphing, the solution to the system of equations is the point of intersection. Write the word intersection on the graph. So just remember, any point, any location where two lines cross or intersect, that's a solution. Everywhere the two lines touch, think of it that way. Everywhere the two lines touch is a solution. That's why most cases, most of the time, your lines will look something like that. The slopes will be different and they're just going to cross 90% of the time or more. But sometimes there are some special cases. And we're going to start by talking about that. And we're going to visually see what it looks like. Okay, so would it be possible to have a system of equations with no solution? Is it possible to have, in other words, is it possible to have two lines that would give you no solution? What would it look like? How would we describe it? Think of two lines. Most of the times, two lines will do this somehow, right? They'll cross. That's one solution. What would it look like if they have no solution? In other words, never touch. What's that? They don't cross. How do we describe that? Parallel, yeah. Parallel lines have no solution in a system. So it is possible to have no solution, and that happens when the two lines are parallel. Let's say there is no solution when the system is parallel. I'm going to write in parentheses two little bars like that. This is the mathematical symbol for parallel. So from now on, if you see me write that, it means parallel. It's a little shortcut. There is parallel lines. Okay, focus on this, please. Would it be possible, our second little bubble there, to have a system of equations with infinitely many solutions? Again, let's go back to the thought that when two lines touch once, that's one solution. When two lines are parallel, now we know that's no solution. How can you get infinitely many solutions? Enough that you can't count them all, ever. Remember, every touch of the lines is a solution. How could they be that they touch infinitely many times? Think of lines. We can even look here. Obviously, how many solutions is this? How many times is it touching? Once, and that's the only time they'll ever touch. That's one solution. How many solutions is this? What did we say? They're parallel lines. No solution. What does this appear to be? Yeah, both lines are overlapping, right? That's when you have infinitely many solutions. How many points are there on a line? Infinitely many. And if they're all overlapping, then every single one of those is a solution. And that's infinitely many. So here's our response. Yes, there is infinitely, I'm going to be lazy. You guys know the infinity symbol, right? Infinitely or infinite many solutions when the lines overlap. Okay. So when the lines overlap, that's infinitely many solutions. Okay, write that down. And now on this table, we're going to look at the three possibilities whenever we have two lines in a system. Okay, so we can either have one solution, no solution, or infinitely many. Okay, so we can have one solution when they touch once, right? We can have no solution when they never touch, because we have parallel lines. So go ahead and write that. No, touch once. Most of the time, almost 100%, this is what's going to happen. Every so often, the two equations will represent parallel lines. So they have no solution. And again, every so often, the lines overlap. And that means there's infinitely many solutions. So let's go ahead and write that down. One solution, no solution, infinitely many solutions. And a lot of it has to do with the slope in the y-intercept. Okay. So let's talk about that. So here we have one line that has a negative slope and one line that has a positive slope. Okay. So lines have different slopes. If the lines have different slopes, doesn't even have to be one positive, one negative, just different numbers for the slope. They intersect at one point. Now, in order to have parallel lines, what do you think has to be? What do you think the slopes have to be? They have to be the same. Lines have this, for no solution, the lines have same slope. So the slopes have to be the same and different y-intercepts. How do I know they're different? This one is a negative number and the y-intercept here is a positive number. So if the slopes are the same and the y-intercepts, then they're going to be parallel lines, so no solution. Now for the lines to be overlapping, they have to have the same slope and the same y-intercept. You see, they both have this y-intercept here, whatever that is. Can you open the door, please? Okay, guys, moving on. So now we're going to refresh our memory on how to graph lines. But we're going to graph two lines on the same coordinate plane. And hopefully they intersect somewhere. If they intersect somewhere, whatever that location is, that's the solution. Okay? So let's refresh our memories. Everybody get ready. I noticed that both equations are in slope-intercept form. That's good because those are the easiest lines to graph. So let's start with this one. Y equals 1/2 x plus 1. So I'm going to write down the slope and the y-intercept because I need those two numbers. Okay? So let's pluck them out of here. You remember where the slope number is, where the y-intercept number is? Help me out, please. Which number is the slope? 1. So that means the y-intercept is 1. Let's write those down. The coefficient for x, that's our slope. The number you add or subtract will be our y-intercept. So now let's remember how to graph using those numbers. We're going to look at the 1 first. Please pay attention. We're going to look at this 1. Go to your y-axis, look for 1. This is our first point. This is our starting point. Put a point there. And now we're going to use the slope to find more points. And we may have to find several points, because one of these points that we find is going to be the solution point. Okay? So remember what we do? We start at 1. And if the slope is 1 over 2, how much do I go up or down? Up 1, to the right 2. That's the rise, 1, and the run is 2. So let's find that point. Up 1 over 2. And then another one, continue from there, up 1 over 2. Continue again. And I'll just do that one. It could connect at the very edge. That's not enough points, because what if our solution is down here? Can I find some more points that way? Sure can. Reverse this. Instead of going up and to the right, we're going to go down and to the left. So we're going to go down 1 and to the left 2. Just reverse what you're doing. Instead of up 1, go down 1 and to the left 2. I don't know which one is the solution. So one of those is going to be our solution point. Now make your line. It has to be a continuous line all the way, like so. Okay, that's our first line. Let's move on to this line. Y equals negative x plus 7. Okay. All right, so here we go. We need a slope and a y-intercept for this one. So let's look at our slope number. It just says negative. What number is there? Negative 1. Thank you. So the slope is negative 1. And since there's no denominator, we give it a denominator of 1. Remember that? If it's just an integer here, 7, negative 2, whatever, give it a denominator of 1, because that's going to be the run. So the y-intercept is 7, positive 7. You see how it says plus 7? That's positive 7. So let's go to positive 7, everybody. That's our starting point. You always start with that. And then it's negative 1 over 1. So what do I do to find more points? Go down. It's negative 1. Down 1 and to the right 1. You always go to the right if you find these. And lo and behold, look, I find, you see which is a solution point? That one right there. I'm going to circle it and then draw your line. Okay, so we just solved basically our first system by graphing. We just have to figure out the coordinates. So we have to figure out the x and the y number. So I'm going to start at 0, go over on the x-axis. I go to 4. So the x number is 4. Then, 4. Then how much do I go up? 3. 1, 2, 3. That's this 3. So the coordinates are 4, 3. So where it says solution, 4, 3. Okay? So if we were to plug in 4, 3 into both of these equations, it would work in both. All right? Let's try the next one, number 2. Same thing. Help me out, please. What's the slope number? 3 over 2. That's not too difficult. The coefficient brackets. What's the y-intercept? 0. If you don't have a number added or subtracted, it's 0. Okay, so let's graph that one. We're going to put a point at 0, and then we go up 3 to the right 2. So everybody go up 3 to the right 2 from this point. And it looks like that's as many points as I can do that way. Now, because our solution may be down here somewhere, I want to plot some points this way. So instead of up and to the right, let's go down 3 and to the left 2. Okay? Down 3 and to the left 2. Everybody do it. Come on. Down 3 spots. 1, 2, 3. To the right 2. 1, 2, 3. To the right 2. And that's as many points as I can plot there. One of those is our solution. Okay, so let's go. Let's make a line. Okay. Let's go on to our second line. This one. Okay. So for the second line, the slope is 1 over 2. And the y-intercept, is it 2 or negative 2? Negative. That minus tells us it's negative. Okay. All right. So let's look for negative 2 on the y-axis. That's right there. This is telling us put our first point there. Okay. Now, what are we going to do to find more points? Slope is 1/2. Help me out now. Really? Nobody? Do I go up? Do I go down? It's positive, right? Yeah, I'm going to go up 1 to the right 2. And then up 1 to the right 2. Do you see it's where is it going to cross? I already see it. It's not going to cross anywhere here, right? Where are these two lines going to cross, intersect? Yeah. -2, -3, it looks like. Down 1 and to the left 2. That's why we always make points on both sides. Perfect. So there is the points I'm going to use to figure out that our solution is -2, -3. It's right there. Okay. And that location is -2 and -3. So that's our solution, -2, -3. Okay. Okay. Let's go ahead. We're not going to do all 3 of these. We're only going to do this one. Tomorrow we're going to work on this. And on the other side, we're only going to do these 2 graphs. And that's all our notes for today, okay? Okay, so let's continue. It says, when solving a system of equations by graphing, equations should first be written in point-slope form. Point-slope form. That's y equals mx plus b. And so what we're going to do is, mostly tomorrow, but a little bit today, practice rewriting equations A through C. That's A, B, and C. We're only going to do A right now because we'll need that one today. Okay? Yes. We're almost done. Okay? We got 1, 2, 3. We're going to do this one. We want this equation that's in standard form. It's like this. But we want to force it to look this way. And we can do it by doing one thing. If I remove 2x, right? If I get rid of that 2x, you see that y would be all by itself? So I just want to get rid of 2x, and then we're done. How do I get rid of that term, 2x? I'll give you a hint. What's the opposite of 2x? Negative 2x. If I add 2x with negative 2x, it's 0. It zeroes out. That's what we're going to do. We're going to add the opposite. But the rule is whatever you do on one side of the equal sign, you got to do on the other. So we got to put a negative 2x over here and see what we get. Okay, so now I got 2x, take away 2x. That cancels out to 0. Let's write down what we have now. On the left side, we only have y, positive y. So good, we want that. On the other side, we have 7 and negative 2x. We've talked about this before. If I combine 7 and negative 2x, they don't mix. It's like adding water and oil together. They stay separate. The reason is 7 is a constant. It's just a number. Negative 2x is a variable term. It has a number and a variable. So they don't combine to make like 5x. They stay separate. So that's how we're going to write them. We're going to write negative 2x because it didn't combine with 7. And since that's a positive 7, plus 7. And that's it. We're done. But now we can graph that if we need to. I know the slope. I know the y-intercept. I'm ready to go for graphing. Okay? We're going to use that skill on the other side. Okay? We're almost done. Flip your paper over. We're going to do 3 and 4. And we'll worry about the other ones tomorrow. Okay. So we're going to continue graphing. Let's start with y equals negative 1/2 x plus 3. Okay? Again, we want the slope and the y-intercept. Okay, what's our slope for this top equation? Negative 1/2. We already have a denominator, so we're good. What's the y-intercept? Looks like it's 3. Okay? All right. So now, let's graph. Where do we start? Looks like we start at 3. Put a point at 3. And this is negative 1/2. So we go down 1 to the right 2. Okay. And just to be on the safe side, the solution may be up here. Let's do the reverse. Instead of down 1 to the right 2, let's go up 1 and to the left 2. Up 1 to the left 2. Right there. Because you never know where your solution is going to be. That's probably good enough. So let's graph this line. The key here is make sure your lines are as accurate as possible. That's why I make a lot of points. Okay? So that's one line. Okay. Y equals 5. That forms a line. What's the slope for this line? Y equals 5. 0, yeah. It doesn't have an x. Do you notice that? No x? So no x, no, no slope. And 0 slopes look a particular way. We talked about it. Well, let's write down the y-intercept. It's 5. Does anyone remember what a 0 slope looks like? It's a special kind of line. Huh? It doesn't touch the x. It's actually going to be parallel to the x. It's going to go something like this. It's horizontal. Very good. Where is it going to cross the y-axis? 5. Yeah, because that's the y-intercept. So here, put a 5. Actually, everywhere along that 5, make points. Well, obviously, I see where it's going to cross now, though. It's going to cross right here. It's a horizontal line, so it's perfectly horizontal. I made a bunch of points, but the point that it's going to intersect at is right there. So whenever you have y equals a number, it's just going to be a perfectly horizontal line. And this one's right there. Okay? And so what are the coordinates there? If I go across the x, it's negative 4. If I go up to see what the y is, it's 5. So the solution is -4, 5. Okay. Perfect. Looks good. Any questions on that? Okay. We're almost done. Got one more. So the thing with this one, I see that I'm going to have to rewrite this a little bit like we did in that example we just did. So I'm going to write the m and the b for this one up here. So if my slope number is 2, how do I write it with rise over run? 2 over 1. And over here, just 1. Positive 1. So now we know it's going to cross at 1 on the y, right there. And we go up 2 over 1. And then I'm going to go down 2 into the left 1. You can always tell when you're going in the reverse order if the points are correct, because they're all going to fall in line. Yeah, I want this to become so natural for you that it's like, oh my God, this is so easy. I'm glad we got this. This is work. Okay, so there's one line. We're almost done. This is in standard form, not slope intercept, right? I want to get rid of this negative 2x on the left side. What's the opposite? Okay, write it there and over here. Again, this is negative 2x and that's positive 2x. When you add them, they make 0. It's just y is left, that's all. I only have plus y, so it's just y. Now, can I combine these to make 0x? They stay separate. I got positive 2x and minus 2. Okay? So now this is my equation. Slope is 2 over 1. Y-intercept is negative 2. What do you notice about the slope here and the slope there? They're the same. What do you notice about the y-intercepts? Yeah. So this is going to be something not a little different. Let's graph it. Negative 2. There's my point. Again, go up 2 over 1. What do you notice is happening? What's happening here? Yeah, the lines are parallel. And so since the lines are parallel, they will never touch. Since they never touch, no solution. Okay? So today, this is what we're going to practice. I'm going to pass out the sheet. Okay? I'll just leave this here for you.